All right, let's look at the homework 16.8, problem number 7. All right, so let's do this problem. All right, so we want to use the Stokes theorem to evaluate this double integral. All right, remember that according to the Stokes theorem, as long as you have the same boundary, we can use a simpler surface. All right, in this case, we're looking at the hemisphere, which looks like this. All right. Instead of this, hemisphere S, we can use the disk, which is the base of this hemisphere. So this integral that we are looking for is going to be, right? We can just integrate, right, the curl of this given vector field. Then we can just do dot with the S vector, right, over the disk, not the surface S, right? So let's compute the curl, right? So the curl of vector field F is going to be, right? So we have vector I, vector J, vector K, right? And partial with respect to X, and a partial with respect to Y, and a partial with respect to Z. Right, X component is e to the xy cosine of Z. So Y component is x squared Z. Right, then the Z component is xy. Right, so this is going to be equal to, right, so first component, partial of y, partial of xy with respect to y, so it's x minus partial of x squared times z with respect to z would be x squared. Right, and the second component is partial of this guy with respect to z would be, right, e to the xy, just a number. Right, partial derivative of cosine of z with respect to z would be negative sine of z. Right, then minus, let's see, partial of xy with respect to y, so it's going to be minus y. Right, so I can't put the comma there. Right, so here's a comma, and last component is partial of x squared z with respect to x is 2xz minus partial of this guy. So you have, let's say, x e to the xy cosine of z. All right, but if you're looking at the D, right, then you can see that normal vector is going to be simply vector I, because it's a positive x direction. So we have, right, so we have an integral. Right, so you have all this guy, but it's x value is 0 on D, so we can plug in 0 here. So you have x is 0, so 0 minus 0 is 0. Right, and x is 0, so e to the 0 is 1, so it's going to be negative sine z minus y. And x is 0 here, 0 here, so this is 0 too. Right, then the normal vector is just the I vector, which is just going to be 1, 0, 0. Right, then we're going to do dA over this disk D. Right, but as you can see, if you take the dot product, you can see that this is going to be 0 plus 0 plus 0. So this is actually 0. Integral 0 over anything is actually all 0. Right? So therefore, the value of the integral is actually 0. So let's type it in. Right? We got 0 there. Right? And submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.